Hi, Jordan. Hi, Jordan. Thank you for being here at the Requirements Engineering podcast, and welcome.
Thank you. Pleasure to be here. Good to meet you both.
Awesome. So let's see. Let's get started. Just if you could give us a quick background about yourself, that also what you guys do at QRA Corp. Probably if you could share like the type of clients you work with, just share some numbers, and we'll move from there.
Sure. So I'm Jordan Kyriakidis. I'm the co-founder and CEO of QRA. We've been around, I would say, close to a decade now. Maybe not quite. My background, I call myself an accidental entrepreneur. I kind of fell on this almost by accident. My actual background is in academia, actually. For about 15 years or so, I was a professor of theoretical physics. Quantum nanotechnology and quantum computing was actually my specialty. What started about people say people buy a Harley when they hit a midlife crisis. I started a tech company, right? I'm not sure which one is more dangerous.
Well, it's a good thing you got out of that quantum stuff. So
you're never
that's going nowhere.
You're never actually out. That's a whole other podcast. I'm happy to talk about that as well. But what started me down the current path is someone approached me, the chief scientist of a large aerospace company, for a project in quantum computing, as it happened. I thought at that point it would be in 7-8 months project. I'd put a PhD student on it. I'd get some funding. Everything would be fine. I thought what he was talking about was not going to work. And that was about 15 years ago. So I was wrong. It was not only an 8-month project. It's consumed my entire life now. I was right that what he was trying to do didn't actually work. But what I didn't appreciate at the time is the underlying reason and the underlying business problem. And we started off trying to verify models, like Simulink design models, implementation models, to solve the V&V problem. Not knowing much about the space and engineering or anything like that, but just developing algorithms. As we got deeper and deeper into it, we realized that part of the problem, we thought we were solving the problem in first principles right at the beginning. It turns out we were not. A lot of problems are already problems by the time they get to the design stage, and there's this whole thing of engineering and stakeholder requirements, solicitation, and a lot of the future problems are baked in there. And so we said, okay, we got to move even further to the left, if time goes to the right, to look at requirements. Then we changed all the technology we used. Instead of using kind of formal mathematical methods and code analysis tool, we switched to natural language processing, and that led us to where we are. Now. So long, convoluted stories. Right now, we mainly analyze requirements, both an eye towards benefiting the project and avoiding rework down the line. So it's a very targeted approach to requirements. Our companies would be maybe not that dissimilar to Visure's companies: automotive, energy, aerospace, medical devices, and semiconductors. I would say that encapsulates, close to 80 to 90% of all our companies. They're broad industries, so their business drivers are all different, but they have some similarities. One is that they are in regulated industries. Certification and regulation is a big, important thing. There is a lot of change happening. Digitalization is sweeping all these industries, and software is getting deeper and deeper into the core of what they do, whereas maybe yesterday or yesteryear, they were primarily hardware companies building actually physical components. They still do that, but now it's all driven by software. So, and there is a level of anxiety in the industries over the changes that are coming and how to best accommodate these changes. Right? I would say that's the 10,000-foot view. Right?
Wow, nice. There's a lot to unpack here, but I want to start with the more basic stuff, which is pretty much the problem that you saw. 15 years ago was in this entire requirement solicitation phase. And it's funny because obviously it's still a problem, especially in the industries that you mentioned that you guys work in. We still obviously see those problems that people do face an issue writing great requirements. They don't even perhaps understand the real importance of tracing requirements. That's pretty much the issues we face it. So what would you say for those people listening, if you could briefly explain to them what really makes a great requirement, why are they really important on it, and then we move from there.
Yeah, I'll start maybe with the why and talk about, why are requirements so important. I would say even our opinions on this have changed over the years, right? And the there is some quarters where they say, requirements are less important now because everyone's moving towards agile principles and you don't need that anymore. That is, I would say, very clearly untrue. And people who are involved in the systems
You can
engineering
say it
processes,
wrong. You can say it
yeah,
wrong.
wrong. Yeah, it is quite wrong.
Yeah.
And the practitioners know that, right? So I would say there's several reasons why requirements are important, right? One, to my mind, one of the most important things is it communicates a shared understanding of what it is you're actually going to do to everyone on the team, right? And the requirements document is that. It helps with alignment, how to get your testing aligned with your designers, aligned with your architects, and aligned with your stakeholders. It generates an alignment, and it helps also with scoping of the project, right? What's not in the requirement is as important as what is in the requirement. It helps kind of set the boundaries of what you are going to do and what you are not going to do. And of course, it also helps with a more, let's say, practical point of giving marching orders to the next stage of the development, right? And because of all these things, requirements is not a one and done, right? Especially the shared understanding as teams get more dispersed. And I would say to get more, I call it delocalized, right? To kind of spread out all over the globe, and the work becomes now more asynchronous. Developing a shared understanding is more difficult and more important. And requirements are not one and done because they evolve as the project actually evolves, right? If you just set the requirement, if you say the only purpose of requirement is to give our testers what to test and the designers what to design, and then after that you don't leave it, you're in for a world of hurt because the shared understanding of what the project is about evolves as the development evolves, and the requirements need to keep pace with that to really.
That's the old waterfall approach, right?
The one and done. It is the old waterfall approach, and that if it ever worked at all, I would say even the practitioners of waterfall never really practiced strict waterfall. That's actually a bit of a straw man. But to the extent that works at all, it works only if you know exactly what you're doing, or if someone else is paying you to do that, and they want to know exactly what it is you're going to do and when you're going to do it. But most of the time now, we don't actually know the obstacles that are in our way, right? And so requirements help you, and the evolution of requirements help you define those knowns and the unknowns. Bit of a long-winded answer, I guess.
No, it totally makes sense.
Well, one of the things that we typically talk to customers about is, it's the knowing what you're going to build, and then how do you know when you're done? And coming, from the here's all the requirements, but then how do you even know that you met those requirements? Because it goes back to what you were talking about with when you originally got started was validation and verification. And that's where you realize, hey, the requirements were bad, so we need to go back a step and find out and fix the requirements so that we know how to verify those requirements. So.
That's right. Yeah, if your requirements are ambiguous or not written very well, different people have a different understanding of what that actually means. So, this definition of done is very important. And if different people have different definitions of done, and that's not encoded anywhere, well, you wonder why there's rework involved.
Exactly.
Have you looked at the specificity of requirements, and I guess this kind of goes into maybe more some of the characteristics that you see of really good requirements. Can you kind of comment about that?
So yeah, I can. And so I would say in some ways you can think of it this being a solved problem in principle, right? 'Cause lots of
Mm-hmm.
bodies have published standards on what makes a good requirement. NASA was one of the first to do it. INCOSE does it. IEEE does it. Most big kind of engineering, especially systems engineering kind of societies, have a set of guidelines. Probably the most comprehensive guidelines is the INCOSE guide. Um,
Mm-hmm.
but the problem with that is not that it's wrong, is that it's very difficult to implement, right? It's just a checklist or a document, right? And so, um, and not every rule or every characteristic is equally important. Some are more important than others. And that's where we put our own spin on it, where we develop these 16 problem types, we call them, that we think out of all the characteristics that make a good requirement, all the rules you should follow, these 16 are the most important. Specificity or singularity or atomicity is among the most important one of those, because in order to verify a requirement, to go to your earlier point, Jeff, of how do you know you're done? If you have a
Yeah.
requirement that specifies only a single thing, the test is very targeted to that. And when we're done is when these tests pass, right? But if your requirement has two or three different things all kind of mushed together, then it's difficult to know when you're done because what if only some of your tests pass, some of your tests fail? Does that mean this requirement is met? It's only part of it is met, part of it is not met, and it's these little wobbly kind of things that actually are the seeds from which big problems fractures can occur in the product. So singularity, I think, is an important, a very important part. It should be as specific as possible. But this old Einstein quote: "Things should be as simple as possible, but not simpler." Right? The same thing goes with the
Yeah.
requirement. They should be as specific as possible, but not more so, because and sometimes we see that these requirements are overly specific, that they don't actually know. It's okay to not know the specifics of what you're going to do early on in the project if you actually don't know. But if you overly specify, say, the gauge of a wire or the bandwidth of a cat cable or something like that too early on, you're going to go down a path that maybe you don't need to go down that path earlier on, right? So it's important to be as specific as possible. But if you don't actually know, don't fake it and write a specific requirement just for the sake of getting a specific requirement.
I think I've
Um,
heard that before. Don't fake it. Um,
yeah. Don't fake it. And not knowing is okay.
yeah, exactly.
At least you should be explicit. The whole point is to be very explicit about everything. So singularity is definitely a big problem that we see. Another one are optional escape clauses. Those are also a problem. And by what I mean by optional escape clauses is the tester or someone else downstream from the requirement has the option to escape and not have to count this, right? So, for example, things like this system should verify all applicable standards, such as, and they name two or three of them, right? Well, what does that mean? Is it
Okay.
really all the standards, right?
Mm-hmm.
That's essentially unbounded scope, right? You list these two. Are these two more important than the other, or is it only these two, or what do you actually mean, right? So it's probably better to put in practice. Such a requirement should be better written as, the system shall conform to the following standards, and then in brackets say TBD, right? And so then you don't yet know what standards you're going to specify, but there's going to be something coming. The requirement is not done yet.
We'll tell you when you ask.
Yeah. Now, if it gets down to the validation stage at the end and that still says TBD, that's a problem, right? But when you're actually writing it for fun, if you don't know it in the design stage, well, then, don't specify something that you don't know. So that's another one we see often, and trigger words such as is one problem. I just added this optional escape clause there. So that's another one. Other ones are inconsistency, right? The requirements are written in different styles from one to the other. That's why templates actually are an important part to enforce consistency. you kind of see this say in coding, right? Almost all coding shops have a style guide to how they write code, right? Even something simple
Yep.
as what sorts of indentation they should use, what should the naming convention be, and this is just so that if other people see it, they kind of understand, and if something's off, you notice it right away, right? So a template's
It's kind of like the
something.
dictionary.
Exactly. Yeah, it's kind
Yeah.
of like a dictionary, both in the terminology you use, but also in how you actually the format of the requirements. You know, like subject, action, object, right?
Yeah.
And keep that consistent is helps. It helps spot anomalies. Um, I would say those are some of those are like the technical issues that we see. There are also, let's call it, I don't know what to call it, sociological issues as well, where oftentimes the author is also the evaluator of the requirements. So
Oh.
I know that I am a good writer. I know I'm a good writer because I write it, I read it, and I know exactly what I mean. So obviously it's very clear, right?
Yeah.
Now, if you read my writing, that's a whole different ball game, right? So writing things down. The purpose of writing requirements is not so you can understand. The purpose of writing requirements is for other people to understand, and so it's important to give it to them and ask them, do you understand what this means? What is your understanding of this? So it's a team. It's a team effort.
I mean, and that kind of goes even to vague words and weak words and things like that, where you have a perfectly clear understanding of words like easy to use or something like that,
Yeah,
and everybody else has a completely different view of that. So,
yeah, we see
I,
that perfect example. Yeah,
yeah, I mean
yeah.
that makes a lot of sense.
Immediately
Yeah,
is another one. That what do you mean by immediately? I'm a physicist, so what I think of immediate may not be the same thing as you think of
yeah.
immediate. Immediate could be like, is it a femtosecond or is it 2 seconds or is it this afternoon? Or what does immediate mean?
Oh yeah, yeah. That's true.
Yeah.
In the post office, that could be days. So,
Exactly, exactly, right? And if the requirement is you want a response within days, and you're ready immediately, and the tester now tests it down to the nanosecond, well, that's going to add some
yeah.
cost to your system, right?
Yeah. Um, you mentioned a little bit about encode templates. I mean encode guideline, the guideline template. I'm not sure if you could also expand a little bit more on the years template and other templates that you're seeing that are pretty much as well getting some kind of popularity in the industry.
Yeah, and actually, I personally have, I would say, I flip-flopped over the years on the use of templates. I started out actually being against templates because I thought if you use templates, it's an excuse to turn your brain off. You just follow a template and you think you'll be okay, right? But I think
Yeah.
since then, I've actually become an advocate of templates. I think templates are good. Everyone should use templates. Um, ERS templates is probably the most common one we see. ERS, you guys probably know, your viewers may not, or your listeners may not, or both. ERS stands for Easy Authoring of Requirements Syntax. And so there is an ERS and there is an ERS Plus. It was developed, I believe, originally by Alistair Maven, who was working at Rolls-Royce at the time in the engine department, and so in aerospace. That's what started it. Aerospace is still uses it a lot, but even we see medical device companies use it a lot. We see some automotive companies use it, semiconductors companies use it, so it is used quite a bit. I wouldn't say it's prevalent in the sense that I would say still is considerably less than 50%, but
Hmm.
among the companies that do use templates, and they're usually the ones who are more mature companies that use templates, ears is a predominant. If they don't use ears, they use something that's very similar to ears. Right? And I think of 7 templates. I think there's about 5 or 7. I can't remember right now. But there are a set of templates. For example, one requirement may be a ubiquitous template. That this is a requirement that must always be true all the time, no excuses, should always be present, right? Other ones are state driven, right? If the system is in a particular state, then it must behave in this manner, right?
Hmm.
That's
Right.
not ubiquitous, it's state driven. There's other ones that are event driven, right? you're operating, but when this event happens, you need to go down this execution path, right?
Well, it kind of makes sense. All these things came out of somebody developing an engine, which is very event driven and state driven. So
that's right. So they were
that makes a lot of sense.
Yeah, they're able to encapsulate these ones, and they work most of the time. We have other customers that use different templates, but they're all generally the same vibe. Let's say, right? They're all very similar.
Totally. Is there much difference between those and the INCOSI or even IIBA? I mean, there's a lot of different types of templates out there.
Yeah, there are.
It sounds like the EARS one is more driven towards more of the embedded development, that certification type environment compared to some of the other ones. Is that true? Or
I would say it is. That's the largest use case. I wouldn't say it's exclusively to that.
Mm-hmm.
I would say it's functional requirements is probably a better way to describe EARS. The best 3 to 4 functional requirements.
Okay, yeah,
less
that makes
suited,
sense.
For example, stakeholder needs, right? So if you're a business analyst and you are eliciting just stakeholder needs from which the detailed functional requirements will be written, then EARS is not necessary to write in EARS. And maybe overkill at that stage. Right?
Yeah, I could see that.
If in terms of INCOSI and other standards bodies, I don't think they specify any particular template other than to say, use of a template is a good thing, and the company should have a template and a style guide that they use for the requirements, and they identify all these other characteristics that requirements should have, like atomicity, active voice instead of passive voice, and I think there's about 40 rules or so that INCOSI specifies that are the rules you should follow in order to have a good requirement. Right? And templates, I would say, is one way to kind of automatically enforces most of those rules. Right?
And Jordan, how can the listeners pretty much question themselves on what template they should choose in this sense? Do you have any recommendations on that end?
One, they should use tooling, and they should use KiwiScribe to help them with that. That's my first recommendation. But I admit I may be biased in that. But there are questions they can ask for EARS in particular. Is I would say the biggest problem of companies trying to use the EARS template specifically is that they default to the ubiquitous requirement, right? And so the ubiquitous requirements are really the hammer, right? These are things that must be true all the time, right? And very rarely would, especially a software system, have behavior that should be true all the time. So the question to ask yourself is, can I envision any circumstances where this statement actually should not be true, right? Is it true only in a very specific set of instances? Now, it may be hard to really enumerate the situations where this requirement should or should not be adhered to, but just the fact that you admit to yourself that this should not be universally true tells you that you shouldn't use this particular template. You should use another one. Right?
It kind of forces more analysis, obviously.
It helps more analysis, yeah. So what we're trying to do now is develop a series of prompts, of questions to ask yourself, and that will lead you down to tell you which template you can actually use. So ask these questions up front. Right?
Exactly.
Okay.
Makes total sense. I mean, we spoke a little bit about writing great requirements, a little bit about templates as well. What challenges do you see, if you see any, in the requirements methodology process in general? If you could share some.
What problems we see or challenges?
Yeah, just common. You could say common mistakes that teams do make during this requirements elicitation phase.
Yeah, I would say a lot of the stuff we touched earlier, that the requirements aren't singular, they're inconsistent. and they are, they're just unclear. Right? Really, what you want your requirements at the end of the day to be clear, consistent, and correct. Right? And most of the issues and requirements come across when these aren't clear, consistent, and correct. I would say the challenges that a lot of the customers that we see facing now is it's difficult to instill this discipline onto the engineering teams because it's not yet recognized. In my mind, requirements writing is an engineering activity. You should bring to it an engineer's mind when you write requirements, as opposed to someone writing prose, right? So even though it's writing, it's not writing class, it's engineering. And only now are we seeing, we call requirements engineering. We see people with the title of requirement engineers. That is something that's still relatively new, and it's not really yet internalized in a lot of the companies. They see it almost as a necessary evil, not as something core to the product, right? As opposed to say testing, right? They say testing. Obviously, you have to have a test engineers. Otherwise, you're not a serious organization if you don't even have test engineers testing, your systems, right? They don't have the same view for requirements. To be frank, it didn't need to in the past. Right? It's only now that it's actually emerging. And I have theories about why that's emerging now, but it's becoming more and more important.
Well, we see the same thing from customers who use Excel spreadsheets and Word documents to do their engineering, and it's not until they get to this point where nothing is working anymore, and they're completely can't figure out what's going on before they even think about having a requirements management tool of any kind to to actually keep track of those things automatically for them. So I definitely, we feel the same thing from our customers that you're seeing. So they just hadn't put a lot of effort into it.
That's right. Yeah, it hasn't seemed to be a very important thing, and people don't write requirements because they love writing requirements, right? Right? They write requirements because they have to write requirements, right? They can't get away with it, right? If there was a way they could have gotten away with it, they would, right?
Yes.
That's something that we should remember as we develop tooling for it, that we try to make it easy for them and have some kind of empathy for them. It's not really what the core job of what they want to do. And so, we spend a fair bit of time, as I bet you guys do, just educating the market, telling them why this is important to do. And the reason you're having all these issues in the later stages is because in the earlier stages, you've already sown the seeds of future problems and you didn't even realize you were doing that. And so if you want to eliminate problems at the source, you have to put more rigor in the front end of your process. And the value you gain from that compounds over time, right? And over time, if you look at most projects and you look at the cost curve and how does the cost increase as time goes on, it's an exponential curve, right? They burn money at the end and start doing all these rework, and the deadlines are come and gone, so they're putting more resources in it to hurry it up. A lot of these problems stemmed from earlier on. If you invest then, the value compounds, and you lower the cost curve overall. That also hints. Go ahead.
Well, it's the same thing when you're talking about writing code, right? If you write, if you find problems early in the development process, you don't have as big a problem at the end of the process. So it's very similar to in the requirement space that we typically don't see, and I'm sure you see the same thing. You find somebody that just went through some horrific project or whatever, and everything blew up, and they finally figured out they have to fix their requirements for the next one. And that's where, so we don't have to do a lot of education sometimes because they already know that this was a huge problem.
Yeah, we call it project trauma.
Yeah, exactly. And we're the closest trauma centers. So
that's right.
So
in fact, some of the early questions we asked when we were looking at customers to see if they are, or prospective customers, see if they are a good fit for us. Some of the early questions we ask is, one, do you use a requirements management tool? Right? And so if you do, it doesn't mean everything is fine, but it means you have some level of
Understand.
understanding of the importance of requirements in your system if you just have a tool, even if you're not using it properly. The fact that you have a tool is you're already one step. You're already one step.
There's some respect involved.
That's right. And then also, have you experienced project trauma in the past? Right now, I'm not the salesperson, so I am not the most I'm not the best person to have these conversations. But essentially, that's what we probe for. Are there any project traumas, and have they diagnosed it? Right? The related issue. This is the problem of communicating this a new way of doing things in the new age. Is what we're saying is you invest earlier on in order to realize benefits down the line. Right? So the line engineers that are focused only on one thing, they don't see the overall scope, so they don't maybe appreciate, nor should they, what the overall process looks like. Right? It's only at the higher level, like project lead, who sees the whole picture and who has some kind of some level of experience and has seen when things go astray. That those are the ones that kind of understand the issue and can see the value.
Right.
Yeah, makes total sense. At the beginning, you were talking. I mean, obviously, that now more than ever, with this entire digitalization era that we're entering, that we are now, it's more important to write requirements and perhaps even embrace technologies. One of those technologies is definitely AI. I'm sure you're probably seeing it firsthand. How do you think AI technology will affect this entire requirements engineering approach in general?
Total game changer. I would say that I would say not. I would even be more specific than just AI and talk about large layered neural nets and large language models in particular, right? So, like most people, I have been obsessed with ChatGPT and seeing how far I can push it, how you can twist it one way or the other, and it's very clear that this is going to have a huge impact, right? Yeah. How precisely is it going to affect systems engineering? Let's talk about just that subset for once. I would say it's still unclear, but clearly the implications are there, right? And the way I see it, taking a step back, is there are, I just speak at a higher level now, maybe a bit too high, so you can bring me down if you want. What we're seeing now is, if you talk about building a complex system, there's generally three phases. There is design, build, and test, right? And you kind of go and you iterate in circles, right? What we're seeing now with these with AI, I call them automated agents. Large language model is one, but there's other types of AI as well. Is that each of these phases, both the design and the build and the test, are being automated, but also transitions between these phases are also automated. And so we're nearing a stage, and we're going to near a stage, I don't know when, but not 50 years away, right? Also not 2 years away, where that whole cycle can progress without human in the loop. That means that cycle is going to happen 10,000 times faster than we have now.
Wow.
That means the way we design products is going to be very different, right? It's almost going to resemble more like a kind of evolution as opposed to the way we do this top-down approach now. That means that the role of the human is going to be sit at a higher level and guide these automated agents, right? And put guardrails up and say, go in this direction, don't go in that direction. And so LLMs is a perfect example of that, right? LLMs are extremely impressive, but they cannot run wild on their own. They still need the human interaction to guide them into one direction. So the real value of LLM is going to be how you interact with the LLM, what kinds of questions you ask, what kinds of responses you're going to get back. And there's going to be additional tooling that is the interface between the humans and their actually domain level needs and these LLMs who do what they do good at, who do what they're good at, and how to almost broker between these two is going to be where tooling is going to be needed in the future, right? And so in terms of
is that more like, because you were kind of talking about guiding, is that more like more specific LLMs or just restricted versions of that?
It's going to be, I think it's pretty, the science is pretty clear that large language models work better than small language models. So I think that's going
Hmm.
to keep on going in that direction, right? What's not clear to me yet is if that is something that's innate into how neural nets are designed and built, or that
Right.
just something that has the first thing that works so far are these large language models, right? I somehow think it's a former, but that's still open. Um, However, what's also clear right now is the LLMs that exist today are really astonishingly good at giving general guidance and general
Right.
principles, and they actually write. They write quite well. It's surprising how well they're better than most humans actually. The writing ability.
Yeah.
In fact, that's almost a problem because it seems they're much more sure of themselves than they actually ought to be,
Yeah,
right?
exactly.
And so, um, and so, but as you get down to the level of detail, they need to verify what they're saying. Then you need to get down to the more specifics, and that is still, you still need that domain expertise. You still need that
Exactly. Yeah.
human domain knowledge to actually probe it and say, well, this seems fishy. I'm not. I'm just going to cut this part out, right? And so
Yeah.
it's you need still that um, you still need that judge and the evaluator of the results of these LLMs, right?
I mean, if you've played with this, I mean, I have too. I was like, please, write some requirements for, a web login screen, and it popped out 10, pretty decent, requirements. I even said write them as shall statements, and it does all that. But then you kind of start looking at it. It's like, okay, how but those need to be broken down because they're not as specific as what you would think. Now, I'm sure that there's probably ways to guide it more to make them
Yeah,
more specific, but there is there's something there. It's just not there yet.
yeah. That's they're not ready for.
Yeah,
They are great tools for tool builders like
Yeah.
ourselves to use. I
yeah,
would say they're not
exactly.
ready for the domain level users to use yet, right? And I think and I think most of the when you're building a complicated system, I would say most of the energy and most of the excitement from an engineer point of view is not the general kind of statements, but really what is specific about this particular
Yep.
thing you're building for this particular use cases. And each
Hmm.
project has a very specific, maybe in your facility, you have only certain types of tools to implement a solution. That's a constraint. And maybe you only have certain ability, certain kinds of tests you can do in your facility. That
Right.
limits what you write in your requirements, right? And the customer may have certain specific needs that limits it. So if it's these really you can think of I think in terms of edge cases, and as systems become more complex and as the complexity goes, you can think of the phase space as getting higher and higher dimensions, right? So if
Hmm.
you take a shape um, at low dimensions, it has very few edges, but as you start going higher and higher dimension, everything becomes an edge, right? So if you
Yeah.
go complex enough, every point in phase space is an edge to something, right? So everything becomes now an edge case. So it becomes and it's these outliers actually is the value and the interesting case, right? So all that to be said, I don't want to shit on them. I don't know if I can say this on the podcast, but they are
No, all good, all
they are
good.
astonishing. I would say I am a proponent of AI and proponent of these tools to use them, but have your eyes wide open as you use them. They're a tool that are very useful, and eventually they will be used as just as a matter of course, just like autocoders are now, right? When you use Simulink, you
Yeah.
use autocoders.
You're right.
Just like how we use CAD design, right? I see it basically as an extension of that, but it's a different beast altogether, right? I would say the LLMs now start stretching what even we mean by an algorithm, what we mean by automation. It's really pushing the boundaries, which in general I think is a good thing.
Yeah, it's pretty. I mean, it's pretty interesting to be at this point in time. So it's
Yeah.
we're on the brink of something. It's just what it is going to be still to be determined.
Yeah, it's very, very much an exciting time.
Yeah, for sure. And I mean, I completely agree with what you're sharing. And definitely, that's what will also bring a drastic reduction in product development in general, especially in this space. It will accelerate just stuff way more rapidly and completely change the game. So, Jordan, unfortunately, we're reaching the end of this interview. Time just flew by. But before, I mean, we let you go, I wanted to ask you a couple questions. The first one, do you want to add anything else? Anything that do you think is really important for our listeners to go away with?
Yeah, I can add a few things. We talked a lot about like writing requirements, and we talked about a lot of specific rules, and we talked and also jumped at a high level of what the future holds. If we stay in the, say, the middle level now, and we could talk about general tips on how to write better requirements, right? This is more of a rules of thumb, not Encoder rules that thou shalt do X, right? But just general principles that we've seen. We've been in the game long enough, and we've seen the companies that do well, and we kind of probe and say, well, how do you guys do that? And we found some similarities among these high-end companies.
Interesting.
And one of them is to write in layers, right? Not write in layers, not start from like stakeholder needs. Then we're going to write the high-level requirements. Then we're going to write the low-level requirements. Is you kind of write them all, but you write them in layers. And over time, over editing, you increase the resolution and increase the specificity of these requirements over time, right? And I think that this idea of writing in layers of successive edits actually generally does well. Another thing
that's really interesting.
we can adopt from actual writers is, there's adage in writing is good writing is actually good editing, right? And the first draft is always crap, right? And so the important thing is to get it down there and then edit. If you can't write a good requirement, an atomic requirement right off the bat, okay, write a non-atomic requirement that you later atomicize, right? It's easy to write an atomic requirement if you first have a requirement that's not atomic, than to start with a blank page and start writing atomic requirement, right? The third one is what we already mentioned. Requirements writing is an engineering activity, and to think of it as an engineering activity, not as a creative writing kind of class or writing in general. It's engineering. And the fourth one is to measure. A lot of these things, the issue that we're talking about, can in fact be measured, right? And can be automated. And you don't need, just like spell check or grammar check, right? It's just like that. A lot of these things humans can do, but it's underemployment for a human to do. Humans should think at a higher level. So a lot of these issues, requirements, singularity is one, inconsistency is another. These can be automated, just measurement. Get tools that actually do this measurement for you, and then you decide what to do with the results of that measurement. I would say those are kind of an encapsulation of best practices at maybe a higher level than individual rules.
That's a pretty good list. I'd love for you at some point to, write a paper or something on the layering approach, because I think that's something that gets lost, I think, a little in a lot of customers. So unless you already have one, I don't know.
No, we don't have one. So it came, you guys probably seen the development V. How a lot of your customers use, and usually the way it's depicted, it sort of leads to a waterfall approach. And you go down the left side and you go up the other side. But in reality, it's all of those happening in parallel, and
exactly.
Which is actually not. It's actually a good thing to do that in parallel, right? But that means not have more communication has to happen now, and this is also the kind of layering approach, right? Oftentimes we have companies where they get a requirement or they get a stakeholder need. The first thing they do is they'll write a bit of code, right? Or they'll check the plant to see if they can build something like that, right? And then they go back and they write requirements. That's actually, to my mind, a reasonable thing to do, as long as you go back and actually write the requirements. You may need some exploration first, right?
Well, we seem to see a lot of customers recently that because they've been using Excel or Word, they're very single level thinking. You know, they've written all their requirements and it's all in one document. And then when you start talking to them about, you know, having multiple levels of requirements, it starts stretching their imagination a little bit. So that's why, you know, that was very interesting to me, because it has been coming up quite frequently. So
yeah, they probably vision like nested bullet point lists in their Word document. Right?
Yeah, if that. Sometimes it's just a list, you know, a straight list, and that's what they work off of. And it's like, oh my gosh, you know, how do you know, that's just no wonders they're coming to talk to us. So
yeah. Project trauma, man.
Yeah, exactly. I mean, those four are pretty. Those are outstanding ones. Good tips.
Good. You got to give the title for the next blog post now.
There you go. You're welcome.
We'll be sure to give you credit.
Marcelo
seems to have been frozen there, huh?
Yeah, maybe. Do you think there's anything left that you want to cover, or?
I don't think so. I think it was a good discussion.
Okay.
Easily could have riffed for another couple hours here.
Yeah, and you know, believe me, I'd love to do that, because these are all things that I keep absorbing a bunch of these types of things, and it's like, oh my gosh, so what's going on? You know, and there's so much stuff happening, like especially with the AI and all these other natural language things that are really starting to make things even more interesting than what they were. I think he was saying, what do you think the difference between a successful project is and an unsuccessful, or is there some definition between the two?
Well, I think it's depending on the size of a project, and if we're mainly talking about large kind of products in a regulated industry, or complicated products that take years to develop in a regulated industry, there's lots of things that can go wrong. So I would say it's not, you couldn't really say that requirements are the sole issue. There's lots of personnel problems. There's lots of most of the problems.
No, it's always requirements, people, Jordan. Right? It's always requirements.
So there are a host of issues, but I would say the most accidents that happen are either attributed, really are a few buckets that most big problems can fall into. One is just a human error, or a poor manufacturing, a poor implementation, or poor definition of what it was that you were going to build, which is a requirements issue, right? And so a lot of those stem right from the early stages. Like, what are the requirements? How are you going to verify these requirements, and then how are you going to validate that you actually built what you wanted to build? So I would say in the concept phase of a large product development is where most of the errors occurred, and about half of that comes from requirements.
Okay. Great.
Wow. Okay.
Anything else,
Perfect.
Marcelo, you want to?
No, and just Jordan, where can people find more about you, QRA Corp?
So QRAcorp.com. Go to the website to get all the information. If they want to reach out to me directly, you can find me on LinkedIn. My email is jordan@QRAcorp.com. You can just reach out. I'm easy to find online. As long as you write my name down there, they'll be able to find me. There aren't many Jordan Kyriakidis around.
Awesome. So yeah, we'll place the URLs, the show notes as well. Yeah.
Awesome.
We really appreciate your time. Thanks for the great insight. So this is really helpful.
Yeah, appreciate it. Yeah,
helps me too, because I like hearing about some of these things. So
I like talking about it. So it was a lot of fun. Thanks, guys.